Now, let us have a look at Coulomb's law in vector form. So, let us consider this three-dimensional coordinate axis x, y and z, and let us consider 2-point charges having position vectors, let us say r1 and r2, and this is charge q1 and this is charge q2, and let us join them. Let us call this point A and let us call this point B. This is our origin O, and because I have not put any sign in front of the charges, it means that they are both positive, and so there will be repulsion along the line joining the two charges. So, the force of repulsion will be in this direction. Now, we have a little nomenclature that you need to learn. This is just a convention, but this is the convention we follow, so you need to learn this convention. Let me put point A here, where you can clearly see that, and this is point B. Let me remove this from here. Right. This is R1 and this is R2. The force acting on charge Q1 because of charge Q2, we call this force F12 with a vector sign, because we are doing the vector form. And the force acting on charge Q2 because of charge Q1, we call that F21, right. Now, earlier in class 11 you learnt vectors, and this is our vector OA, this is our vector OB, and so this is vector AB, and so clearly we can write vector OA plus vector AB will give you vector OB. OA plus AB equal to OB. What we need to find is this distance AB, because in Coulomb's law we need the distance between the two charges, but that does not have a position vector as yet. So, we need to find that. So, we basically need to find AB. So, AB is here. So, vector AB is equal to OB vector minus OA vector. Right. So, now you see what we have done is, in terms of R1 and R2, we have been able to find the value of the vector AB, which gives us in vectors the distance AB. So, vector AB therefore would be vector OB. What is vector OB? Vector OB is R2 vector minus vector OA. OA is R1, so minus R1 vector. So, we have AB vector in terms of the known position vectors of charges Q1 and Q2. This, in short, we can write in this fashion: AB vector is R21 vector, and I am using the convention that your NCERT textbook is using. Some books have a different convention of writing this as R12, but we would stick to our NCERT textbook because that is the recommended textbook for you. Okay, if you follow any other textbook, you would find a little difference at this point. So, it is clear now. So, I can now go back and use Coulomb's law that we have already learned, the scalar form of it, and apply this knowledge that we found out into that. So, we know from Coulomb's law that F is k times Q1 Q2 by R square. If I make this a vector, then right hand side also needs to be a vector. Okay? Now, which vector am I talking about? Am I talking about F12 or F21? Let us say we start off with F12. So, I put this subscript here, F12. Now, what is the direction of F12? F12 is acting in this direction from B to A, right? But A to B is R21. So, B to A would be R12. So, and unit vector in the direction of F12. So, I have not changed the expression at all because I am multiplying by 1 really. So, magnitude does not change, but multiplying by the vector gives this scalar quantity a direction now. Now, we have vector quantities on both sides, right. So, basically it is almost complete, but we can write it in other forms. So, let us write it in other forms. So, we can have this. Now, this r is basically this distance AB, and AB we found out is r21. So, we have r21 square, but this is only the magnitude, not the vector. We are interested only in the magnitude of the distance. So, we put the magnitude sign, the modulus, times of course r12 cap. This also could have been r12 because magnitude of r21 and magnitude of r12 is the same thing. So, just to keep consonants, I will change it and I make it r12. It comes to the same thing because the magnitude measured from A to B or magnitude measured from B to A, they are the same thing. Now, this I can further write in this fashion. Look at this now. Earlier in class 11 when we were doing vectors, there is one more thing that you learnt, that, let me get some space, right. So, we learnt that unit vector A is the vector A divided by its magnitude, right. You recall this? So, we are going to use this idea here and write this unit vector in terms of the vector divided by its magnitude. So, I get this then q1 q2 by r12 modulus squared, and this vector I write as r12 vector divided by r12 modulus, right. So, that completes the whole structure, but in the denominator you have r12 cubed. So, we write this in this fashion, that is k q1 q2 by modulus of r12 whole cubed times r12 vector, and this is our f12 vector. That gives one complete expression of Coulomb's law in vector form. You could try now writing the expression for f21, and as you can clearly see from the diagram, f21 acts exactly opposite to f12. So, from this expression to write f21 would simply be f21 is minus of this whole thing. That is one way to write it. The other way to write it would be using, instead of r12, right, r21, f21 would have r21 here. So, I leave that to you, that is an easy exercise, and that would complete our first topic, Coulomb's law in the scalar form as well as Coulomb's law in vector form. And previous to that, we have also done quantization of charge. So, the whole thing together, we have finished one big chunk of your unit 1. We will continue this lesson. There are more topics to be covered in unit 1 electrostatics. See you again.